Am I audible to all of you? सुन रहे हैं ना तुम लोग?
Satish.
हेलो,
Yes, sir.
सुन रहे हैं ना?
Yes, sir. We can hear you, sir.
Good, good. Okay. Can you see the video of last class? In the last class, we discussed some materials, no? The net is very slow today. So it is not working.
Masses are displaced with different angular displacement.
Can you see the video, students?
System.
No, sir. We can see nothing.
What happened? What happened? Any problem?
No, sir. We can see nothing.
Yeah, yeah. Give me a minute. I'm having severe network issues today. Just give me a minute.
So that we can derive one equation based on these degrees of freedom, and we can solve. It is most important to know what is the
Can
degree
you
of
see the
freedom
screen
of
now? Can you see the screen now?
Yes, sir.
Okay.
the system,
Yes, sir. Yes, sir.
Ask me for any doubts. If you have any doubts, you'll ask me.
so that we can derive one equation based on these degrees of freedom. And we can solve to find the displacement, velocity, or acceleration. That is the amplitude terms of vibration. Now, there may be a single degree of freedom system, 2 degree of freedom systems, or 3 degree of freedom systems are there in the environment that are
Video
occurring.
is not moving.
First, we will see the
Sound is not coming. Hello?
Video is not moving, sir.
Because it is being
It's like
expressed.
showing a photograph.
You try to. You are hearing the sound. Wait, wait. The net is very slow. Have some patience. Buffering.
degree of freedom system. Examples
Can you
of
hear the
that
sound?
shown in first two diagrams, B and C diagrams, in which one spring, one mass is there. C diagram, one disc is attached to one shaft. Now there, C diagram, one disc is attached to one shaft. Now there, in B diagram, spring mass system, that mass has been displaced with distance x, and that x is the only degree to define the motion of the system. That's why it is a single degree of freedom system. In torsional system, one disk is attached to one shaft. If disk is rotated in any direction by angle theta, then it will vibrate along that vertical axis by angle theta, clockwise, anti-clockwise, clockwise, anti-clockwise, like that, with a single degree of freedom. Now in the next example of 2 degrees of freedom system, there I have shown 2 springs and 2 masses, m1 and m2 mass. Now if m1 mass is displaced by x1 distance, m2 mass is displaced by x2 distance, then the system vibrate with 2 degrees of freedom. That's why this system is having 2 degrees of freedom. In B diagram as well as the torsional system, 2 rotors are at that shaft in 2 sides, and these 2 rotors are twisted. One is clockwise, another on anti-clockwise direction by angle theta 1 and theta 2. Therefore, to describe that system, 2 angular displacements are required, theta 1 and theta 2. The equation of motion will be based on these theta 1 and theta 2 for this system. In 3 degrees of freedom system, A and B and C diagrams. In A diagram, 3 masses and 4 springs are there. These 3 masses are displaced with different displacement, x1, x2 and x3. In B diagram, a compound pendulum is there, in which m1, m2, m3 masses are displaced with different angular displacement, theta 1, theta 2 and theta 3. In C diagram, 3 rotors are there attached to a single shaft, and they are rotated again with angle theta 1, theta 2 and theta 3. In all these 3 examples, the displacement, that may be linear or angular, or system displacement, depends on these 3 parameters. That's why it is a 3 degree of freedom system. Such n number of degree freedom system are there that you have to consider. That means, what is degree of freedom? Number of variables or independent variables necessary to completely describe the motion of every particle in the system is called as the degrees of freedom. Now I think you understand that. Next, vibration parameters. All the mechanical systems can be modified by containing 3 basic components: spring, damper and mass. Now here in this diagram I have
Is the
shown
sound not clear?
a human being is there, and in front of him spring is there, one damper,
That much.
one mass is there.
हाँ
Now,
क्लियर नहीं है क्या
what we are studying, vibration parameters. Now,
इतना क्लियर नहीं है.
generally
अच्छा
can be
थोड़ा नेटवर्क का
explained
प्रॉब्लम
in
चल
these
रहा है
three parameters. Which parameters? Displacement, velocity, and acceleration. Based on these three components only, that is spring, damper, and mass. When these components are subjected to constant force, they react with a constant displacement, velocity, and acceleration. For example, in first diagram, observe that human, if apply some force on that spring will displace by some distance. Therefore, I have written one equation below that, F is equal to K into D. What I have got due to that spring? Displacement. Secondly, one damper is there. If I apply some force on that damper, there will be some velocity of that damper in that damper. Therefore, I can get one equation, F is equal to C into V, where F is applied force, V is velocity with which I have applied that, and C is damping coefficient. If I am having one mass, and if I displace it with some acceleration A, then if I apply some force, there I will get an acceleration. Therefore, I can write that equation, F is equal to mass into acceleration. Therefore, when these components are subjected to constant force, then they react with a constant displacement, velocity, and acceleration. I have to measure in vibration these three parameters only, that is displacement, velocity, and acceleration. These things you have to calculate in the vibration. Complicated vibratory motion equations will be there. From that, you are getting the vibration amplitude in these three terms, that is displacement, velocity, and acceleration. So these are the basic vibration parameters you should know. Next, types of vibratory motion. There are different types of vibratory motion. From that, few types we will study one by one. First is free and forced vibration. Free and forced vibration. What is free vibration? When no external force acts on a body. After giving an initial displacement, then the body is said to be under free or natural vibration. Initial disturbance is given to body and system is left to vibrate without influence of external forces. The frequency of free vibration is called as this natural frequency. This also we have previously studied. Frequency of free vibration is called as a natural frequency. What is free vibration? When initial displacement or disturbance is given to system and system is now left to vibrate without influence of external force, and this type of vibration is called as a free vibration. The frequency of this free vibration is called a natural frequency. What is forced vibration? When the vibrating system is simultaneously or stimulated by external forces, then this type of vibration is called as forced vibration. When the body vibrates under the influence of external force, then the body is said to be under forced vibration. The external forces applied to body is a periodic disturbing force created by unbalance in many times. Remember, the external force applied to body may be a periodic disturbing force created by unbalance many times, that is due to unbalance only. Now, if the excitation frequency matches with natural frequency, there will be resonance occurring in the system. During this forced vibration only, a resonance occurs. Due to external forcing frequency matches with natural frequency, there will be resonance. Remember this. This is regarding free and forced vibration.
Okay, so what did you understand by free and forced vibration? Can anyone say me? Just now you're speaking. Can anyone say me what you understood by free and forced vibration?
In pre-vibration, there will be no external force. Only initial force will be distributed in the system.
So in free vibration and forced vibrations, let me explain you once more. In free vibration, what happens? The body shall vibrate without the influence of external force. That means what? Every body on this earth is having some frequency on which it vibrates. So that frequency is called the natural frequency. Okay. Now, in case of free vibration, what happens is that the object or the body will vibrate in its natural frequency. Okay. Now, forced vibration, what it means? Suppose some external forces are applied on the body because of which it's vibrating. This force may be a periodic disturbance force. So this is called forced vibration. Now, undamping and damping, I'm telling you in a simple manner. So, in undamping structure, what it means? Suppose what happens when you start a generator. Huh? If you see the generator, it is keeping on moving and moving and moving. There will be a time when you have to stop that. So, even after stopping, it vibrates for a few seconds, 2 or 3 seconds, and then eventually stops. Now, this vibration becomes a bit small, 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 and then stops. So that is known as damped vibration. Undamped means the body cannot dissipate. Dissipate means cannot transfer. Transfer the energy to the bottom or to the ground or something else. Okay, so this is the difference between undamped and damped and free vibration and forced vibration.
This we are going to study in detail.
Yeah, I'm having very network issues. Okay, we'll try to finish. Just watch this for some time. Okay, because there is a very much glitch.
What is free vibration? Types of free vibrations. Once again, but this is basic free and forced vibration. Second, undamped and damped vibration. So, what is undamped vibration? When no dissipation of energy is there, this type of vibration is called undamped vibration. No dissipation of energy. What is damping? We have studied previously. Damping is resistance to vibration. That means no resistance to vibration is there due to dampers. At that time, this vibration is called as undamped vibration. That is, no resistance means no dissipation of energy. Now, system without dampers creates undamped vibrations. In many cases, the damping is negligible or very small. For steel, it is 1 to 1.5% only. In many cases, it is very small. In case of undamped vibration, what is damped vibration? When there is a reduction in amplitude of vibration over every cycle, the motion is said to be damped vibration. Dissipation of energy occurs there. That is, resistance to vibration occurs there. That is, reduction in amplitude occurs there. This type of vibration is called as a damped vibration. Vibration amplitude decays. The system with the dampers creates the damped vibration. Remember, the system with damper creates damped vibration. Understand what is undamped vibration and what is damped vibration? No dissipation of energy, and here dissipation of energy occurs in case of damped vibration. Next, deterministic and random vibration. Deterministic vibration, it can be described by implicit mathematical functions as a function of time. These are deterministic, that means we can find the magnitude of these vibrations. But in case of random vibrations, they cannot be predicted. The process can be described by statistical means, that is statistical analysis. In case of deterministic vibration, vibration amplitudes can be determined, can be found easily. But in case of random vibration, the amplitudes of that vibration we have to find by statistical analysis. This kind of analysis is very difficult than that deterministic vibration. Now, example of that random vibration is earthquake. In that we cannot find exactly what is the magnitudes of these vibrations because it's randomly changing. That's why they are random vibrations. Understand deterministic and random vibrations. Next, types of free vibration. We have seen what is free vibration when there is no external force acts on body after giving an initial displacement.
So what you do, it is let us stop this and we'll explain it to you about the basic terms now. Okay. Can you see the PDF? Can you see the PDF student? Okay. So in the video, what we discussed was the basic terminology that was associated with vibration. Hmm. Now, if you see here, certain basic terminology that are used in vibrations. Number one is oscillating motion. The study of vibrations is concerned with the oscillating motion of elastic bodies and the force associated with them. So, the study of vibration is concerned with the oscillating motion of the elastic bodies and the force associated with them. What is oscillating motion body? You all know, we discussed in the last class, the oscillating body means a body is moving to and fro in one direction from one point to another. Like if you take a pendulum and then try to rotate it, this gives you what? An oscillatory motion. When all the bodies which possesses mass and elasticity, they are capable of vibrations. So all the bodies that have mass and elasticity are capable of vibrations. Most engineering mechanics and structures experience vibrations due to some degree in their design. Generally requires consideration of their oscillatory motion. Now, if you see a heavy machinery or heavy structure, so that every structure it will exhibit some vibratory motions. Now, if that happens and the vibration is not taken care of, then definitely it will not serve the purpose. So, in most of the machines as well as in cars, during the design, this oscillatory motion thing is always taken into consideration. Okay? The oscillatory systems can broadly be characterized as linear or non-linear. So what is linear system and what is non-linear system? In linear system, the principle of superposition holds good. In non-linear, the principle of superposition does not hold. So, if the question comes like, in what type of systems the principle of superposition holds good for, you just say linear systems. And if it doesn't hold good, then it is non-linear system. So in this way, we have to define this thing. So is it clear, everyone, what I was telling you all? Is it clear? My sound is breaking, someone told.
Hello, sir.
I'm
Can you hear me?
साउंड का बहुत प्रॉब्लम हो रहा है क्या मेरा? हेलो, मैं सुनाई नहीं दे रहा तुम लोग.
Hello.
हाँ, मेरा नेटवर्क का
Hello.
प्रॉब्लम. हाँ, सुनाई नहीं दे रहा है क्या तुम लोग को अच्छी तरह आज?
दे रहा है सर. हम लोग का सुनाई दे रहा है.
दे रहा है ना? कोई कोई लोग बोल रहा है कि सुनाई नहीं दे रहा है. नेटवर्क का प्रॉब्लम है उन लोग का कि मेरा पता नहीं.
हाँ बीच हाँ. In the middle of the
बीच में
conversation,
अटक जाता हूँ ना, मतलब
it's
साउंड.
breaking.
या द नेटवर्क इज हैविंग वेरी. ओके, आज के लिए जितना डाउट है पूछो, तो बाकी मैं नेक्स्ट कोई कंटिन्यू करूँगा.
Sir,
बोलो.
what thing causes damping in the vibration?
देखो, डैम्पिंग क्या है पता है? इन द वाइब्रेशन व्हाट
Resistance to
हैपेंस.
the vibration.
या रेजिस्टेंस टू द वाइब्रेशन. So damping, if it is the resistance to the vibration, then सबसे अच्छा एग्जांपल क्या है पता है? बाइक का जो शॉक एब्जॉर्बर है, हैव यू सीन द शॉक एब्जॉर्बर ऑफ बाइक्स?
हाँ yes sir. Socket jabber.
तो क्या होता है, अगर उस शॉक एब्जॉर्बर की जगह एक डायरेक्ट स्टिक दिया जाता है, तो तब तो बहुत ज़्यादा वाइब्रेशन करेगा ना. लेकिन ये शॉक एब्जॉर्बर स्प्रिंग की तरह है, तो उसको रहने से क्या होता है, थोड़ा तुम लोग को वाइब्रेशन कम मिलता है ना, है कि नहीं?
Yes sir.
स्मूथ हो जाता है ना तुम लोग का राइड. ये सर.
Yes sir.
So that is
Yeah.
how you can say one small example of damping. समझा?
Normally, all body have oscillation motion.
और एक बार पूछो तो, और एक बार पूछो, मुझे सुनाई नहीं रहा है.
Do all body has
Hmm.
oscillation motion
All
or yeah,
body does not
vibration
have
motion?
vibration. तो all body is having. Even you are having some vibration. I am having some vibration.
Okay, okay, okay.
कुछ तो वाइब्रेशन होगा. ये ऑसिलेटरी मोशन
So,
से
sir,
डिफरेंट है. ऑसिलेटरी मोशन मतलब क्या है? पेंडुलम को देखा तुम लोगों ने? Have you
yes,
seen
sir.
pendulum? So when you bring the pendulum to one side and then bring it down, ask to go it that side, then it eventually comes and goes and comes and goes, no? है कि नहीं? हेलो,
Yes, sir,
हेलो.
yes.
तो उसको क्या कहते हैं?
Ye-
उसको ऑसिलेटरी कहते हैं. समझा?
Yes, sir.
गुड. एनी डाउट एनीवन? और कुछ है तुम्हारा? I don't think so anyone has any doubts, I think.